we need just one log on each side so they can cancel. The thing that's holding us up right now
That two.
is that 2. Where can you put that 2?
Just divide that two.
Well, you could divide it over, but then that makes it a 1/2 over here, so
Can
it.
you bring it up so we can exponent?
Use those properties of logs. Coefficients can turn into exponents. Now you have one log on each side, so you can drop them. Add a square root with that plus or minus, and we get x to be positive or negative 3.
That's.
Can we just get
It can
easy
only
ones
be
like that
3
on
now,
our
can't
homework
it?
now?
Yeah, you always give us heavy when the homework's on steroids.
Yeah.
Oh, what, if you look at your notes, if I give you the odd problems, I worked most of the even problems with our notes examples. I do the same
So the
thing.
evens are easiest.
Yeah, they are easier.
Okay, there's a problem with this. Notice that it can only be positive 3. Do you remember when I talked about logs, I told you the base and the argument both had to be positive? If I plug a 3 in here, that's fine, but can you have log of a negative 3?
So it's just 3.
So x equals 3 is that one answer. So we will have to make sure we are checking on these, that we won't get negative arguments. Just one more thing to pay attention to. Alright. Let's look at another one like this before we try anything different. Alright, so first thing, we have this 3, so it's going to turn into an exponent. What's this negative going to
Can it
do?
be the exponent for
-1.
27? You're welcome.
But can't we not do that because then it'll be 27 and
Hey.
It won't make it a negative. The exponent is
it'll
negative.
make it
Get
one
a
of
fraction.
Yeah, that's what I
Yes, so now you can drop your log, so we get x cubed
3/1.
equals 1/27 if you want to go ahead and take care of that negative exponent. So the opposite of a cube is a cube root. So we get x to be 1/3. Okay, double check if you plug a 1/3 in, do you have to worry about any negative arguments? Nope, so that answer is fine. Is this one okay? Look at this problem. Alright, a little bit different. Any ideas? Okay, if we have 2 logs added together, you can combine those into 1 by multiplying your arguments. Stop it.
What?
I hate it when people pop their fingers, pop their necks. Awful.
Why do you hate it so much?
I don't know, it's one of my many pet peeves. I also can't stand people like picking at their fingernails or tapping their fingernails on things, or I have a lot of pet peeves.
What's a loud one?
drop the log because they only have a log on one side. You can put it in exponential form now. If there's a log on one side, that means 5 to the first power is equal to this. First, we need to set it equal to 0. So if I subtract over my 5. Now we do box method. So what multiplies to 7 and adds to 8? 7 to 0, and we get -7 and negative. You're going to say something.
Can negatives.
We plug them in. X plus 6 and x plus 2 have to both be positive. Can you do -7 plus 6 and get a positive?
Absolutely.
No. Alright, what if you did -1 plus 6? -1 plus 2? Okay. So -1 is our only answer.
So like you don't want those to be negative.
When whatever you're doing the log of has to be positive. So you have to take your answers and plug them in and make sure they're still positive.
So that's the -7 should be negative.
Other questions there? Okay. Ideas? Mm-hmm. Alright, so if I bring that up, we have log base 2 of x minus 1 cubed minus log base 2 of 4 is equal to 5. Those logs are being subtracted.
Divide.
When you condense it, you put the log once and divide those pieces. Alright, so now change to exponential form. So 2 to the 5th equals x minus 1 cubed over 4. Now what? So 2 to the 5th is 32 times 4, 128. How do you get rid of the cube? Cube root. Do you need a plus or minus for that?
No.
No, because it's an odd root. Okay, what is the cube root of 128? Is it pretty?
No, it's 5.
Okay.
5.73
Let's
times
wait just a second. Then what would you do to get your x by itself? Okay, so I'm going to put all this in the calculator at once to get my final decimal. I prefer 4 decimal places. I know the book did 3 last night. So if I type all this in, 6.0397. Double check if you put 6.03 in, your argument is positive, so that is okay.
Maybe 6 point, can we just round up to 4, or we have to keep this one?
I would want more decimal, please. I mean, if you were going to 3, then it would be 6.040. If you were to go into 4, it'd be this. Other questions? Let's try this one. Alright, thoughts? Okay. Can you, if you just look at the side of the equal sign, can you combine the 1 and the log x minus 2? No. If you have some things with a log and some things without, put all the terms with the log on one side and everything without on the other. So it'll be log of 2x plus 1 minus the log of x minus 2 equals 1. Now you have two logs being subtracted. So you can combine it. You write the log one time and divide their arguments. Now what? Do the thing.
Yeah.
Your base is 10.
Our base is 10, so 10 to the first equals 2x plus 1 over x minus 2. So I'm going to multiply my denominator. We distribute, we get 10x minus 20 equals 2x plus 1. So if I put my x's together, subtract over my 2x, you get 8x, add your 20, you get 21. So x is 21 over 8, or 2.625, is that right?
How do you do that?
Well, 1/8. So, first of all, do you have any terms without a log? No. So I don't have to worry about putting all the logs on one side because everything's got a log. Alright, let's just start on each side and condense what we can. If these two logs are subtracted, so it'd be log base A of x minus 1 over x plus 6. Over here, same thing, log base A of x minus 2 over x plus 3. Alright, so we have cleaned it up a lot right now. I have one log on each side, so you can drop the log. Now what? Let's just cross multiply. So we're going to have x minus 1 times the x plus 3 equals the x minus 2 times the x plus 6. So if we FOIL that out, Now what?
Yeah.
Combine that.
So if I subtract my x squared, those both just cancel. So I have 2x minus 3 equals 4x minus 12. So I'm going to subtract over my 2x, add over my 12. And x is 9/2, so 4.5. Double check when you plug 4.5 in, are all four of these things going to be positive? Yeah, so the answer works. So, in this section we have encountered a lot of different types of problems. Kind of a summary of what to do in each scenario might be helpful. So we started out with the exponential problems where you couldn't get a common base. That's what we were looking at yesterday. What did you do if common base wasn't an option? Add a log. So our summary. If you have exponential and you can't get a common base, you just add a log to each side. What do we do if there's a log on one side and not the other? If there's a log on one side, change it to exponential. What if there's a log on each side? Drop the log. If there are multiple logarithms or exponentials, you always need to combine it first. Condense as much as you can.